Hello students, let's do the quick revision of chapter 10 Gravitation. Now, the definition of gravitation, let's do it first. It is a phenomenon of attraction between any two bodies in the universe due to their masses. Gravitational force is a force of attraction between any two bodies in the universe due to their masses. Now, when out of the two bodies, one body is a planet like Earth, then we call this gravitational force as gravity or force of gravity. So gravity can be defined as the phenomenon of attraction between any planet and any body on it or close to it. Or we can also define gravity as the force of attraction between Earth and any body on it or close to it. Or we can say gravity acting on a body is the force with which Earth attracts a body towards itself. Generally, when we say gravity, we are talking about Earth's gravity. Actually, it can be gravity due to any other heavenly body. Now, next, you should know the statement of Newton's universal law of gravitation. Every body in the universe attracts every other body with the force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, then you should know how to express this law in mathematical form. Expression of Newton's universal law of gravitation in mathematical form. Depending upon the marks, you will be writing it directly straightforward, the final mathematical expression, or you will go stepwise. Whenever you are asked to write the mathematical form, you should state the law. Now, the final expression I am discussing here is capital F is capital G m1 m2 over r square, where F is the gravitational force of attraction between two bodies having masses m1 and m2 respectively, and r is the distance between them, or r is the distance between the centers of two bodies. Here capital G is a constant of proportionality called as universal gravitational constant. And you know value of this constant capital G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now whenever you write the mathematical form, you should give the introduction of these terms involved like F, G, M1, M2 and R. Now next is free fall motion. Free fall motion is the motion of a body which is moving only under the influence of gravity. And you know free fall motion is an example of uniformly accelerated motion. Now what is acceleration due to gravity? We know acceleration is change in velocity in unit time. And acceleration due to gravity will be change in velocity in unit time which is produced by gravity alone. It means when a body is falling freely, we know its motion is free fall motion and the body is freely falling body. So we can say acceleration produced in a freely falling body is called as acceleration due to gravity, and it is produced by gravity alone. So when only gravity is acting on the body, then the acceleration is called as acceleration due to gravity. Next, you should know to derive an expression for acceleration due to gravity. So derivation of small g. Small g here represents acceleration due to gravity. Now for this, for any derivation, you should first give the introduction. So here I have not written it as we are doing quick revision, so I have not written the introduction, but we have you must have watched the playlist as it has already been discussed before. So I have written it in short. Introduction, you'll be writing, consider a body having mass small m lying at distance small r from the center of Earth, and let capital M be mass of Earth and F be the force of gravity acting on the body. It means force of gravity is force with which the body is attracted towards the Earth or towards the center of Earth. Now in this case, I have not written here capital R. You can also write here that capital R, let it be the radius of the Earth. Now, after giving the introduction, you can use the two laws. First is according to Newton's universal law of gravitation. This force of gravity F is given by this formula. F is G capital M small m over R square. So number this as 1. Then by using Newton's second law of motion, according to Newton's second law of motion, we can write force of gravity is equal to m into G. So if this body is allowed to drop or allowed to fall freely, we know acceleration produced in this body will be acceleration produced due to gravity, since only we are assuming that force of gravity is acting on the body. So F is mg, 2, number this as 2, and you should also mention where small g is acceleration due to gravity. Similarly, you should mention in the first equation that capital G is a universal gravitational constant. Now comparing 1 and 2, we get F is equal to mg is equal to gmm over r square. So small g is gm over r square. So finally, we have derived an expression for small g, that is acceleration due to gravity. And from this expression, you can answer various questions like state the vectors on which small g value at any point depends upon, and how it depends upon those vectors, like what happens to the value of small g when the distance from the center of our Earth is doubled or tripled, or it becomes 4 times. Next, you should know the importance of Newton's universal law of gravitation. So as per NCERT, 4 points are given. We know that this gravitational force binds us, an atmosphere, in fact everything on Earth or close to Earth, that is bounded to Earth by this gravitational force. So we can say it binds us, an atmosphere, to the Earth. Then we can write the motion of Moon around the Earth. For that, centripetal force required is provided by the gravitational pull of Earth on Moon. Similarly, we can write that motion of planets around the Sun is also due to the gravitational pull of Sun on the planets. And lastly, we can write the tides which are caused in sea or ocean are caused due to the gravitational pull of Sun and Moon on Earth, and in fact water present on Earth. So these points are given in NCERT, so I have discussed only these points. You can write more points, but see that the points, first you prefer these points only, and you can add more points if required. Next is give differences between small g and capital G. We know that small g stands for acceleration due to gravity, and capital G is a constant of proportionality called as universal gravitational constant. Small g is a vector quantity as acceleration is a vector. Capital G is a scalar quantity. Next point you can write, the value of small g varies from place to place and value of capital G is same everywhere. If required, the fourth point can be of the SI units of small g and capital G. You know the SI unit of small g is meter per second square and the SI unit of capital G is Newton meter square per kg square. Now next is give the differences between mass and weight. So first you can write the definitions. Mass is the amount of matter contained in a body or quantity of matter contained in a body. Weight of a body is the force of gravity acting on a body or force with which the earth attracts a body towards its center. Then you can write mass is a scalar, weight is a vector. And we can write the third point as mass of a body can never be 0, weight of a body can be 0. It is 0 at the center of earth. We know weight is force of gravity and it is given by the formula W is equal to mg. So we'll revise the variation topic also now, where we'll just remember that small g value is 0 meter per second square at the center of Earth. Next point is mass of a body is, I think so this point I have told that mass of a body is constant everywhere, weight of a body varies from place to place. So this is the next point. You should first write the definition. Then write mass is a scalar, weight is a vector. Then you can write mass of a body can never be 0, weight can be 0, it is 0 at the center of Earth. Then we can write mass of a body is constant at all the places or everywhere, weight of a body varies from place to place. Now we know that mass is measured by physical, common or beam balance. Weight is measured by spring balance. And lastly, we can write the SI unit of mass is kg and the SI unit of weight is Newton. Now we have this last topic, weight of a body on moon. Now we know weight is given by the formula mg, where m is mass of the given body and g is acceleration due to gravity. Generally, when we say acceleration due to gravity, it is due to gravity of Earth. But here we are talking about weight of a body on moon. So weight of a body on moon, Wm is small m, gm, where m is mass of the body and gm is acceleration due to moon's gravity. Similarly, weight of a body on Earth, We, can be written as mge. As we have discussed just now, that mass of a body is constant everywhere, so m is same. In both the formulae, we have used the same mass because we are talking about the same body's weight on moon and then on Earth. So by using the formula for gm and ge, we have seen the derivation before. So small g is capital G, capital M over r square. So if the body is lying on the surface of moon, then the small r can be replaced by capital Rm. And similarly, if a body is lying on the surface of Earth, on or close to the surface of Earth, we can replace r small r by re square, where re is radius of Earth, here rm is radius of moon, mm is, they are not separate, it is just, let me show you. So this mm is written on this side, see here. So this is the way you should write. Mm stands for mass of moon here. Okay, mass of moon, this is a subscript, small m is a subscript here. So when you put the expressions of gm and ge in the above two expressions for wm and we, if you take their ratio and put the values, do the simplification, cancel out the common terms like capital G, then small m, you will finally get that Wm is approximately equal to 1 by 6 We. It means weight of a body on moon is 1 by 6 times weight of a body on Earth. As mass is constant on moon as well as on Earth, if we are talking about the same body, then this weight is 1 by 6 times weight on Earth, because acceleration due to gravity on moon is 1 by 6 times acceleration due to gravity on Earth. That is, Gm is 1 by 6 times Ge. Now, finally, this point actually we have missed before, variation of G. Now, variation of G, you know that G, small g, is not the constant, it is not a constant quantity. Although for the numericals, we know that we take it as 9.8 meter per second square. But when we remember the formula, small g is capital G, capital M over small r square. So if we move away from the surface of Earth, small r varies. Just one second. So this is the formula for small g at any place. So small g is capital G, capital M over r square when we are talking about a body lying on or close to the surface of Earth. And small g is acceleration due to gravity at any point where the body is lying or may not be lying. Then in that case, capital G is, we know that universal gravitational constant, capital M is mass of Earth, and small r is distance of the point from the center of Earth. So G is inversely proportional to r square. It means as we move away from the surface of Earth, this r will increase and G will decrease. In fact, when r is doubled, G becomes 1 by 4 times. When r is tripled, it becomes 1 by 9 times. So as we move away from the surface of Earth, G value decreases. And if you remember, I have discussed it before also, that Earth is not a perfect sphere. Its shape is not exactly spherical. It is flattened near the poles and bulging near the equator. So because of this, the G value will be different at poles than at the equator. So at different places on Earth, the G value will be different. And when we see, let me draw the diagram here. So here I have drawn roughly a diagram where we can see Earth is not a perfect sphere. It is flattened near the poles and bulging near the equator. So when we see the RP, radius along the poles, that is polar radius, It is smaller than the equatorial radius, that is RE, radius along the equator. So as we have seen, we can see the expressions here. GP is GM over RP square and GE is GM over RE square, where GP is acceleration due to gravity value at poles and GE is its value at the equator, or at any point on the equator. So as RP is less than RE, GP is inversely proportional to this radii. So radius here. So GP will be greater than GE. So acceleration due to gravity will be having maximum value on the surface of Earth at poles. If we want to be more specific, we can say G value is maximum at poles. And as we move away from the surface of Earth, it decreases. And on the surface of Earth at the equator, it is minimum. Now, remember, we are not going to use the same expression when we are asked to talk about the variation of G as we go deep inside the Earth. Okay, but you can remember, although we are not going to use this formula, but remember that when we go deep inside the Earth, as we go deeper, we say that G value again decreases. So G value is maximum at poles on the surface of Earth, and small g value, we can say it is minimum. If we are saying on the surface of Earth, then it is at equator or at all the points on the equator, and otherwise G value is minimum at the center of Earth. It is 0 meter per second square. So small g value is 0 meter per second square, which is the least value at the center of Earth or at infinite distance from Earth, because when the denominator is infinity square, then G value will be 0. So G value is minimum at the center of Earth and at infinite distance from the center of Earth. Now students, hope you remember the rules which you should follow while doing the numericals. Read the question properly, write what is given by using proper symbols. See if any conversion is required, if any physical quantity is not having the proper same unit or unit in the same, not the same unit, but unit in the same system of units, then you should do the conversion if required. And then you should know what you're supposed to find out, and then you should be knowing which formula you're going to use to find out your answer. So here formula involved in this chapter are F is capital G m1 m2 over r square, or F is capital G capital M small m over r square. If any body is out of the two body, one body is a heavenly body like Earth or Moon or any other planet, it means if capital F is a force of gravity, then we can use the symbols capital M and small m for masses of the two bodies. Capital M for mass of the planet and small m for mass of the small body. And remember, r is a distance of the body, or r is a distance between the center of the Earth or center of the planet and center of other body. Or in the above case, r is the distance between the two bodies having masses m1 and m2, or we can say it is the distance between the centers of two bodies. Now, weight is force of gravity, so weight is equal to mg. Now, next is, we know that in this case we are talking about free fall motion. So free fall motion is an example of uniformly accelerated motion. So you can use the three equations of motion. Here we will just replace small a by small g and s by h, because when a body falls freely, it is the height covered by the body. See, v is u plus gt. This is the first equation of motion for a freely falling body. H is ut plus half gt square. V square is u square plus 2gh. So these three equations you can use for a freely falling body. Now this can be a body dropped from certain height or released from certain height or thrown from certain height and moving only under the influence of gravity. Or it can be, these equations can be used for a body which is thrown in the vertically upward direction. Now when a body is thrown in the vertically upward direction at the peak position, we will talk about the final velocity v is 0 meter per second, and small g is taken to be as negative 9.8 meter per second square if the value is not given. If they ask you to take it the value as 10, then you can take small g as minus 10 meter per second square when the body is going in the upward direction, when you throw it in the vertically upward direction. For a body which is coming downwards freely, you can take small u is 0 meter per second square if the body is dropped or released, not thrown. So if a body is dropped or released, u can be taken as 0 meter per second square and small g should be taken as plus 9.8 meter per second square unless the value is given as 10 meter per second square. You should take it plus only, but. So h is the height attained by the body if it is thrown in the vertically upward direction, maximum height attained by the body, or in case of a body which is dropped from certain height, it will be small h represents height from which the body is dropped. Remember, for the motion from the place from where the body is thrown in the vertically upward direction to the peak position, if we consider the time taken for a body to go in the upward direction and time taken for the body to fall from the top to the ground again, they are equal. Generally, we assume that from the ground the body is thrown in the vertically upward direction. So after reaching the peak position, it comes back down and reaches the same point. So when initial and final positions are ground, we can take the time taken by the body to go up is equal to time taken by the body to return down to the ground. I hope you have understood this, and this is a very simple chapter again. So you should not get nervous during the exams. You should be confident enough, and you should be, when you go through when you have any numerical, you are going to follow the same method given to find, formula used, conversion if required, and then proceed. Write the correct formula, put the values, do the calculations, write the answer with the proper unit. Preferably the answer should be correct to 2 decimal places. If you think that calculations are tedious or time consuming, then you can leave the answer in fraction, but still you should, you will lose marks for that, but still you write the unit. If it is time consuming, you can leave it for half mark, because it should not be at the cost of any other answer. So goodbye students, and all the best. See you in the next video.